Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide focused on DTC P2185, which indicates an high voltage issue in the ECT sensor 2 circuit for the Honda Accord models from 2017 to 2023. The Engine Coolant Temperature (ECT) sensor plays a vital role in monitoring the temperature of the coolant circulating in the engine. It provides crucial data to the Powertrain Control Module (PCM), allowing for the optimal performance of the engine. The sensor is typically located near the engine block and is connected through a 2-pin connector. A high voltage reading can lead to incorrect engine performance modifications, since this triplet of components, sensor, wiring, and PCM, communicate effectively for maintaining engine efficiency. Therefore, understanding the implications of DTC P2185 is essential for effective diagnosis and repair. DTC P2185 signifies an issue with the Engine Coolant Temperature Sensor 2 circuit, known as an ECT Sensor 2 circuit high voltage error. The Engine Coolant Temperature (ECT) sensor is crucial for providing accurate coolant temperature readings to the Powertrain Control Module (PCM). Located typically near the engine block, the sensor ensures that the engine operates efficiently by modulating fuel-air mixtures and managing engine timing based on temperature readings. When the signal from this sensor reaches 4.92 volts or more, it triggers the DTC and could indicate a malfunction in the sensor circuit. This can stem from bad wiring, poor connections, or even a faulty sensor itself, necessitating a thorough diagnostic approach to both the sensor and its connection to the PCM. Several factors can lead to the emergence of DTC P2185. Firstly, a high voltage reading from ECT sensor 2, which may exceed the threshold of 4.92 volts, is a primary cause for this diagnostic trouble code. Secondly, poor connections or loose terminals at both the ECT sensor 2 and the PCM connectors can disrupt signal integrity, possibly leading to erratic voltage levels. Lastly, if sensor components become faulty or degraded over time, they may provide incorrect readings, thus triggering the high voltage error. As you begin troubleshooting, it's essential to verify each potential cause methodically to ensure a comprehensive repair. Symptoms associated with DTC P2185 can manifest as several engine performance issues. An overheating engine is often a direct consequence, as false readings from the ECT sensor can mislead the control module about the necessary cooling requirements. Additionally, drivers may notice reduced fuel efficiency, which can occur when the PCM makes incorrect fuel delivery calculations based on faulty temperature data. Erroneous readings on the temperature gauge display might also be evident, giving drivers a false sense of engine temperature that could lead to further complications. Therefore, recognizing these symptoms is crucial for timely diagnostics and repairs. For the first troubleshooting step regarding DTC P2185, begin by positioning the vehicle in the on mode while ensuring the engine is not running. Next, utilize the Honda Diagnostic System (HDS) to examine the voltage reading from ECT sensor 2. You are looking for the voltage to be at or above a threshold of 4.92 volts. If the displayed voltage meets this criterion, your current condition may suggest that there is indeed a problem with the sensor or its wiring. However, if the voltage does not match the threshold, this indicates an intermittent failure or that the system is functioning correctly at that moment. In such a case, it's recommended to inspect the connections or terminals for any signs of looseness or corrosion, as these physical issues could temporarily disrupt the electrical signal. In the second troubleshooting step, with the vehicle still in the off mode, you will need to disconnect the ECT sensor 2's 2P connector. Following this, you will connect terminals A and B using a jumper wire to simulate the sensor's operation. Terminal A is located at female terminal number 1 of the ECT sensor 2 connector, while terminal B is at female terminal number 2. Once connected, turn the vehicle to the on mode again and check the ECT sensor 2 voltage using the HDS. If the voltage still reads 4.92 volts or higher, it suggests that the circuit is intact, and the issue may lie within the sensor itself. Hence, proceed to step 3. If the voltage is not at the expected level, replacing ECT sensor 2 may be necessary, as it indicates that the sensor is malfunctioning. For the third troubleshooting step, first ensure that the vehicle is again in the off mode before removing the jumper wire connecting the ECT sensor 2 2P connector. Turn the vehicle to on mode once more, but keep the connector disconnected. At this stage, you will measure the voltage between 2 specific test points. Using the HDS, check between test point 1, which is located at female terminal number 2 of the ECT sensor 2 connector, and test point 2, which is connected to body ground. Ideally, you should aim for a reading of approximately 5.0 volts. Achieving this voltage indicates that the wiring for the sensor is intact, and you may proceed to the next step. A lower reading would suggest further investigation into the wiring and connections. In the fourth step of troubleshooting, you will start by turning the vehicle to the off mode once again. Jump the SCS line with the HDS and allow for a wait time of over 1 minute for proper resetting. Following that, disconnect the PCM connector E, which contains 80 pins. The next crucial part involves checking for continuity between test points 1 and 2. The first being female terminal number 1 of the ECT sensor 2 2P connector, and the second being pin 45 of the PCM connector E. It's important to ensure that this wire, termed the SG6 wire, is fully operational without any interruptions. If continuity is established, this indicates that the wire is okay for communication. In the absence of continuity, it becomes vital to locate and repair any open circuits in the SG6 wire connecting the ECT sensor 2 to the PCM. For the final troubleshooting step, again ensure the vehicle is in the off mode. Similar to the previous step, initiate a SCS short using the HDS and wait for a minimum of 1 minute. Next, disconnect the PCM connector E, which consists of 80 pins. Now, you will check for continuity between test points, specifically between female terminal number 2 of the ECT sensor 2 2P connector and pin 54 of the PCM connector E. This wire is identified as the TW2 sensor line, and continuity is crucial for proper sensor signaling. If continuity exists, it suggests this wire is functioning correctly, and any other authorized service information should be referenced for resolving the DTC. However, if there's no continuity, separate the stranded wire and conduct repairs along the TW2 sensor line between the PCM and the ECT sensor. After completing all the necessary troubleshooting steps and repairs for DTC P2185, it's imperative to perform a final repair verification. Begin by rechecking the voltage from ECT sensor 2 to confirm it returns to the normal operating range. The voltage should again measure around 4.92 volts or lower to ensure proper functionality. Following a successful voltage check, it's advisable to take the vehicle for a test drive to evaluate its performance under real driving conditions. Monitor for any reappearance of the DTC or any related symptoms, such as overheating or inaccurate temperature gauge readings. A successful outcome would not only ensure that the DTC has cleared, but also confirm that the vehicle operates efficiently without any warning indicators. To minimize future occurrences of DTC P2185 and ensure the longevity of the ECT system, proactive maintenance is essential. Regular inspections of ECT sensors can be beneficial. Make sure to check for any signs of wear, damage, or corrosion affecting the sensor's connectivity. Furthermore, maintaining clean and secure wiring connectors will help ensure that electrical signals remain uninterrupted, reducing the chances of intermittent faults. It's also a good practice to periodically perform routine diagnostic checks on the PCM and associated wiring, especially as vehicles age. Implementing these preventive measures will go a long way in avoiding unexpected breakdowns. In conclusion, understanding the role of the engine coolant temperature sensor 2 is crucial for diagnosing DTC P2185 accurately. Properly functioning components within this circuit are vital for the engine's efficiency and overall performance. By following each troubleshooting step meticulously, one can identify and rectify the underlying issues that lead to high voltage readings from the ECT sensor. Always prioritize checking connections and wire integrity, as these are often overlooked yet common culprits for such DTCs. Preventive maintenance should also be an integral part of vehicle upkeep to avoid future complications. Thus, utilizing this guide armed with the correct knowledge will enable successful repairs and optimal vehicle operation. Please like and subscribe to the channel. See you next time.